Welcome to The Explainer. Have you ever really wondered what's going on inside the mind of an AI like ChatGPT when it's writing? Well, today we're popping the hood. We're going to break down the surprisingly simple game that powers all these complex conversations we're having with AI.
Right, so the big question is, how does an AI actually go from a simple prompt to, a whole coherent paragraph? It can feel like magic, honestly, maybe even like it's thinking. But when you get right down to it, the actual mechanism is, well, it's surprisingly straightforward.
It all boils down to this one concept, autoregressive modeling. It sounds super technical, I know, but it's really just a fancy way of saying the AI is playing a highly sophisticated game of guess the next word over and over and over again, just at an unbelievable speed. Okay, so let's really get into this. This one idea, just predicting the very next word, is the absolute fundamental building block for these massive language models that we're all starting to use every single day. Think of it this way. Autoregressive models are all about predicting the future, but just one word at a time. And this is totally different from other types of models, which are called bidirectional. Those are built more like an editor. They look at a whole sentence, forwards and backwards, to fill in a blank. Like trying to solve to be or not to blank.
And this image just nails the difference, right? A bidirectional model can see the beginning and the end to figure out what goes in the middle. But our autoregressive model, it's more like a writer. It can only move forward, building on the words it's already put down to decide what comes next.
So what does that look like in practice? Well, if you give a model the prompt to recite the first law, its entire job, its whole purpose, is to calculate the most probable next word. So let's say it picks of. Great. Now its new reality is recite the first law of. And it just does the whole thing again and again, building a sentence one piece at a time. Okay, so how do you actually teach an AI to get good at this game? Because let's be honest, knowing the rules is one thing, but becoming a grandmaster at next word prediction is something else entirely.
It starts with reading, a lot of reading. We're talking about huge chunks of the internet, millions of digital books, scientific papers, you name it. This is basically the AI's library. And the more it reads, and the more varied that reading is, the more it can write about with real nuance. But before any learning can happen, all that text needs to be carefully prepared. You can't just dump it in. It gets broken down into smaller pieces called tokens, it's cleaned up, and then it's basically chopped into countless examples of here's a sequence of words, and here's the correct next word. Now, it sounds simple enough, right? Just see a sentence, predict the next word. But, and this is a big but, this seemingly straightforward process actually creates some really difficult, really thorny problems for the engineers building these things. And these challenges are, well, they're huge. They range from the obvious things, like needing gigantic data sets and fleets of supercomputers, to more subtle and tricky issues inside the training itself, like something called exposure bias. So let's talk about one of the biggest ones, exposure bias. Think of it this way. During training, the AI has training wheels on. To help it learn faster, it's always shown the perfect, correct start of a sentence before it has to make its next guess. That's a technique called teacher forcing. But then, you take the training wheels off. When it's time to write for real, what's called inference, it's all on its own. And if it makes one tiny mistake early on, that mistake becomes part of the new prompt for the next word. And that's how one little wobble can quickly spiral into a cascade of bigger and bigger errors. And another huge problem, memory. The longer your conversation with an AI gets, the more it has to remember. But here's the kicker. The cost doesn't just go up in a straight line, it grows quadratically. So doubling the conversation length doesn't just double the work, it squares it. That is exactly why an AI can sometimes forget what you told it at the very beginning of a long chat. So we have all these tough problems. How do we get around them? Well, this is where the engineering gets really clever. People have come up with some very smart solutions to make these models write better and faster. The most basic approach is called greedy decoding, and it is, well, it's greedy. At every single step, it just grabs the one word that has the highest probability right now and moves on. It's fast, for sure, but it's also really short-sighted and can lead to some pretty weird or repetitive text. So a much smarter way to do it is called beam search. This is like teaching the AI to keep a few different drafts going in its head at the same time.
It keeps track of a handful of the most likely sentence paths, explores them all for a few more steps, and only then does it commit to the one that looks the most promising overall.
And you can see the trade-off here, right? Beam search almost always gives you better, more human-like text. But that quality comes at a price. It takes a lot more computational horsepower to pull off. It's that classic dilemma, speed versus quality.
Now, to try and get the best of both worlds, there's this really cool new technique called speculative decoding. It's basically an awesome efficiency hack. You have a small, zippy model that sketches out a quick draft of the next few words, and then the big, powerful model comes in and just checks its work all at once. It saves a ton of time. Okay, so we've gone through all this, the complex training, the clever tricks for generating text, but what's the end result? Why does any of this actually matter to you when you're just typing a question into a chat window?
Well, the payoff for all this work is something that's kind of mind-blowing. It's an emergent ability called in-context learning. The model gets so incredibly good at just predicting the next word that it accidentally learns grammar, facts, and even some forms of reasoning. It can then do completely new things based on just a few examples in your prompt without ever being retrained.
And this leaves us with a really fascinating and kind of huge final thought. If all of this incredible, flexible, creative ability really just comes from playing a game of guess the next word, it forces us to ask a much deeper question. What do we really mean by intelligence and understanding in the first place?